Containers using multiple ways, either simply through the terminal using certain Docker commands, all the Docker commands, okay, which is what we did in lab 2. Okay, or we can go ahead and create a custom image from which we can you can use Docker file, build a Docker file, and from which we can get a custom image, and from that image we can create a container, which is what we did in lab 3, right? And then we went ahead and created containers, basically not individual containers, multiple containers, where one container would be the front end, another container would be a supporting container which has the database of that front end web application, which by using Docker Compose, right? That was what we did in lab 4. Now we are going to learn something called as Docker Swarm. So there is, see, whenever you, especially if you have multiple containers that are configured and created, you may want to manage these containers, manage them, okay? Or what we call as orchestration of the containers. Okay, for that purpose, we have something which is called as Docker Swarm. Now, this Docker Swarm does orchestration of containers. Which containers? Containers which are created by Docker and only Docker. Okay, there are other container creation vendors like this. There's something called as Rocket.D. There is other ones which are available in the market. Okay, it's not that Docker is the only one that can be used for creation of containers. Okay, but Docker Swarm can only manage the containers which are created using Docker, because of obviously they have they want to create a monopoly. So they end up managing those only data which is created using Docker, okay, which makes this slightly less advantageous than that of Kubernetes. Kubernetes is also used for management and orchestration of containers, but it is a little more ahead because of the fact that it can support the management and orchestration of containers, which are not only created by Docker. Okay, making it, there is no monopoly. There is a lot of what do you say, scope of managing containers created by multiple vendors and companies. Okay,
Just
so
quick question, like in the so we are going to like learn Kubernetes as well, yeah?
yeah, Kubernetes we're going to learn later on, and I'm going to
Okay.
yeah. So right now I'm just taking you through. Actually, I could have skipped this topic because actually it's not there part of your curriculum.
Okay.
It's only Kubernetes. Okay, when we're talking about orchestration containers, we only have Kubernetes in our curriculum. But I am teaching this because we can at least do a comparative study and see where, how, and most of the logic what we're going to learn here is going to be used again in Kubernetes. What are containers? Containers are the ones which have the code, our web application, you could say, and along with its dependency. Okay, dependency, probably generally if it's a web application, the dependency is most likely going to be a web server, like Nginx or something like that. Okay, Nginx. This is an example of a web server which is used along for the code. Okay, so this is a container. Container is nothing but consisting of a software unit which consists of the code and its dependency, okay, which can be deployed on any platform, configured once and deployed in any platform, okay, whether it be Windows, Linux, or whichever be it, it can run on that. Okay, now the thing is, these containers, this web application, suppose this web application code. Okay, now we do know how to access the web application, right? We do port mapping whenever we do the running container, we write port mapping. Say the container's port number is 80 for the Nginx web server, and this is running on this machine. Okay, so this EC2 machine's port number is say 8000. So we do port mapping. 8000, which is on the left hand side, is mapped to port number 80 of the container that is on the right hand side. Then when I take the IP address of this machine, colon port number which is on the left hand side, which is 8000, I will be able to see my web application. We have done that on several occasions, right? Able to recollect, right?
Yeah, of course. Yeah.
Yes. So now what we're going to do is this website, which is this web application. Initially, it won't have much of a problem because it's just starting out. It's like a startup or something like that. But when it becomes a popular website, the number of users who are accessing that website will drastically increase. Okay, and sometimes it will be it becomes a little unpredictable. right? So one container is not sufficient to run this particular web application. You may require multiple replicas of this web application, multiple containers, which are replicas of this one to manage the user traffic. Okay, so these containers, replicas must be created. That means multiple containers have to be created to manage this user traffic load. If this is a streaming platform for a sports website, and the number of users who are accessing it for the football World Cup or something like that is drastically large, then I may want to scale up by increasing the number of containers to manage that user traffic, to meet the demand, you could say. Okay. So then what happens? We need to have something that will help us to manage, to scale up these containers, to scale down the containers, scale up, create what we call as replicas. Basically, they are nothing but replicas of that existing container. Okay, scale up, maybe even scale down. Okay, and if one of these containers, anything happens to this container, then what will happen? What should happen? What kind of disaster recovery will this orchestration or management tool do? Okay, so in terms of orchestration, what is it going to do if anything happens to any one of those containers? What's the action plan in mind? Okay, all these things have to be looked into when we are doing orchestration of these containers. Okay, that is why all these are only used for creation purpose. For management purpose, we're using Docker Swarm. Okay, and like the term indicates, swarm nothing but, like you would have heard, swarm of bees, right? Swarm of bees,
Yep.
same logic. Okay, it's like me having a cluster of machines. Now the thing is, these containers, now all when I scale up the number of containers, sometimes this EC2 machine is not sufficient. It's a T2.micro in my case, right? It's a T2.micro. It's a free tier eligible low capacity system. Maybe if I scale up the number of containers, this one system is not enough to manage those many replicas of containers. I may require more memory and in more system configuration. Then what will I do? I'll create more machines. Okay, probably two of these containers would be running on another machine, which will act like a worker to me. Okay, and maybe the other three would be running on another machine. Basically, I distribute the running containers to other machines. Okay, making it what we call as a cluster, or what we call as a swarm. A swarm. So swarm will nothing but, we're going to consider multiple machines or EC2 machines. Okay. Would be one EC2 machine. This would be another EC2 machine. Basically instances, virtual machines on the cloud environment. Okay. And out of this, generally when you have a swarm of bees, okay, in bees, what is it? We have something called as the queen bee, right? The boss is the queen bee who gives the instructions and everything. And there would be worker bees, right, who listens to what the queen bee says. As simple as that. Same logic is applicable here. Here, there would be one EC2 machine which is going to be considered as the swarm manager. Okay, and there will be other EC2 machines which we consider as worker nodes. Okay, or swarm workers. This would be worker one, maybe this would be swarm worker two. What happens whenever there's a container that is created in the swarm manager, and you may have to replicate it or scale it up. Okay, then what happens? Maybe I will have this and one replica within this machine, the swarm manager itself, and the rest I will allocate it to the other worker nodes. Maybe 4 over here and maybe 3 over here. Okay, making it distributing the what is a running containers to its worker nodes. Okay, plus the swarm manager has to have Docker Swarm installed in it. Basically, you don't need to install it, activate it. You need to activate the Docker Swarm. Actually, when you have Docker installed on any system, when we install Docker onto any system, the Docker Swarm is actually already there. Okay, but it is in deactivated mode. We need to activate it. Okay, at the same. Here also Docker would be installed. Here also Docker would be installed. But in the which machine you want to make the Swarm manager, there what you will do, we need to activate it by typing which command? By typing init command. When I initialize it, what happens? The Docker Swarm gets activated. At the same time, I can set the fact that this EC2 machine is going to be the Swarm. It's like me broadcasting. Okay.